All right, let's take a look at our lesson for today. Today we're going to look at fundamental theorem again, but this time this part is called part 1. This is fundamental theorem part 1. Do we remember what part 2 was? Remember, let's just remind ourselves just so that we're clear. I don't want any confusion. So part 2 was way back here. Part 2, remember we looked at accumulation functions, how that worked. We found derivatives of integrals. Remember that? That was part 2. That's fundamental theorem part 2, is the accumulation function and the derivative of the integral. Remember, they undo each other and we're left with the integrand. Okay, just want to remind you, that was our part 2. Okay, what we're going to be doing today is we're going to be looking at part 1. So part 1, to be honest with you, we use more frequently than part 2. I want to talk about vocab first. So, and we already have looked, this is called a definite integral. This is a definite integral. Why is it a definite integral? It's a definite integral because it has bounds, right? It's got these bounds right here. That's why it's called a definite integral. So they have names, so we're going over vocab. This is formally, it's a formal name. The lower limit of integration is the one on the bottom, and the upper limit of integration is the one on the top. Or lower limit, lower bound, upper bound, however, whatever kind of phrasing you want to use. This little kind of looks like, kind of like an S. This thing, it's called an integral sign. This middle part, whatever's here, is called the integrand. So that's a vocab word. When I talk about the integrand, I'm talking about the functions that occur inside of here. This is the integrand. This piece right here, the dx, we have talked about it before. I'm going to talk about it again. This tells us which variable to integrate. So let's write down what it tells us. So this tells us two things. Number one, it tells us which variable to integrate. Tells us that. And I understand we are in single variable calculus. We really would only have one variable. In multivariable calculus, this is a bigger deal for the first reason, which variable to integrate. The second reason is it tells us when to stop. It tells us when to stop. This is really important. When to stop. If you forget to put this, and some students do, if you forget to put the dx or the dy, then what's to tell you to stop? All right, you might know when to stop, but people reading your work would not know. So it's really important that we write that down, the dx or the dy, whichever variable we're working with. And so this, for us, this is the most important reason for us. It tells us when to stop integrating. Okay. And so what else do we have? The whole thing is called the integral of f from a to b. We don't really normally use this a whole lot, but that would be what you would call the whole thing. And when you find the value of the integral, what you have done is you have evaluated it. So you've evaluated the integral when you found the value. This is a word, a vocab word, that they might use. They might give you the integral and they say evaluate. That just means, work it out and find the answer. Okay, so that's vocab for us. Okay, so now let's look at the formula that goes with fundamental theorem part 1. Fundamental theorem part 1. Here is our formula. I typically don't write this on the formula quiz, this here, right here. It's not something you would need to know for a formula quiz. You would need to know it in order to know how to work a problem. So it won't really appear as a formula for you on the formula quiz. So what does fundamental theorem part 1 do? What it does is it takes this integrand right here, which in this notation is called f prime, and it does the antiderivative of it. The antiderivative of it is f. And then we put this little bracket, or some people like to put like a line. It doesn't matter what you want. And we typically would write our bounds on it. Whatever these numbers are, we would write right here. So our step 1 is to find the antiderivative. We find the antiderivative, we put our little bracket, or whatever kind of notation you want, the bracket like that. I usually don't put this bracket, but they are. The bracket or a line. And then what Fundamental Theorem Part 2 tells us is that we can find the value of the integral if we take the antiderivative and we substitute into it the value of b, and we subtract, substituting into our antiderivative the value of a, f of b minus f of a. That's Fundamental Theorem Part 1. That's the formula that we're going to use on, I think most all of the examples that we have today is this formula, if you will, and this theorem part 1. Okay, so I'm going to pause here for a second. Are we okay? Is everybody okay? All right, so let's look at our very first example, and they say evaluate. If you recall, that's that word that we were looking at earlier. Evaluate means, give me the answer. It's a definite integral because it has numbers on the bounds. Do we remember the name of the kind of integral that has no numbers on the bounds? Do we remember what name that was? Indefinite. It was an indefinite integral. And if you recall, the indefinite integral, all of them require you add what at the end? Plus c. You add plus c. Those are indefinite integrals. They all need a plus c. Definite integrals do not get a plus c. Okay, definite integrals do not get a plus c because we're actually going to evaluate them and get a number. All right, so here we go. So we're going to do the antiderivative of this again. This is called our integrand. That's our integrand. We're going to take the function that's in our integrand and we're going to do the antiderivative of it. So the antiderivative of 4 would be 4x. The antiderivative of 6x, so this exponent is a 1. I would add 1 to 1 and I get 2. And then I would divide by 2. Okay. Then I usually do a bracket like this. Some people do lines, whichever you prefer. I normally do a bracket. And then I put the -2 on the lower bound and the 5 on the upper bound. I'm going to pause here for just a moment. So I've done the first part of Fundamental Theorem Part 1. I've done the antiderivative, and I have put my little bracket there, and I have my numbers there. Is everybody okay? All right, now if that's okay with you, I'm going to take this 6 halves and I'm going to turn it into 3, just because it'll be easier to calculate with. So that's a 3. All right, so now here's where we do our f of b minus f of a. What does that mean? I'm going to take this top one, that's b, and I'm going to put it where the x is there and where the x is there. I'm going to do that first. Okay, so I've got 4 times 5 minus 3 times 5 squared. That's the first part. Now, I highly recommend the second part is subtracted. See, the formula tells us, the formula is over here. The formula tells us that we are supposed to subtract the second part. Okay, that's part of the formula. That's not part of our function. So my recommendation for you is put the subtraction here and then put a bracket so that you remember to distribute the negative to everything inside there. It is very easy, as you are well aware, to forget to distribute a negative. So I would recommend that you make a big deal out of it. Might do subtract and put a big bracket up there. Now what we're going to do is we're going to take the lower bound and we're going to put in here where the x is and there where that x is. We're going to put that both places. Okay, so here we go. So I've got 4 times -2 minus 3 times -2 squared. And that's the formula. Okay, that's the calculus. We are done with calculus now, and now it's arithmetic. And I don't know about y'all, but arithmetic is what drives me crazy. I have a hard time with it. I have to double and triple check what I'm doing. Okay, so let's do our arithmetic. Here we go. So I've got 4 times 5 is 20. Let's see, 5 squared is 25. And, well, I'm just going to do each step. Of course, y'all are, I'm sure, way better arithmetic than I am. You can do fewer steps than I'm doing. I'm just going to work it out piece by piece. So 4 times -2 is -8. Let's see, then I've got -3 times -2 squared is 4. I'm just taking it slow because I'm so terrible at arithmetic. All right, so 20 minus, let's see, 3 times 25 is 75. Okay, so let's see what's going on in here. I have 8 minus 12. 8 minus 12. 8 minus 12, what is that, -20, right? 8 minus 12, okay. -8 minus 12 and -20. Okay, so now I've got 20 minus the -20, so that's 40 minus 75, which I'm finally getting to where, okay, that still is hard for me, but 40 minus 75 is, what, -35. Okay, so that's my answer. Now, again, I'm sure y'all are way better with arithmetic than I am. You can skip a bunch of steps. It doesn't matter. Question? Yes, a minus minus 20. I did 20 plus 20 and I got 40. Yeah, I added it, which I know this is a weird way to do it. You might have done it completely differently, like 20 minus 75 and then added 20. I don't know. Other questions? Are we okay? So that's our very first fundamental theorem, part 1. How are we doing? Okay, so let's practice some more of them. I've got, I think, 4 more examples. And the last one we're going to use our calculator for. I'm going to show you how to do definite integrals on your calculator. You may already know, but if you don't, we'll look at it. Okay, so here we go. They want us to evaluate that. So what I would do first, even before I started to do antiderivatives, is I would rewrite this so that it's easier for me to do an antiderivative too. That's what I would do. So I'm not doing an antiderivative yet. I'm just going to rewrite. So square root of x would be easier to work with if I wrote x to the 1/2. And 1 over x squared would be easier for me to work with it if I wrote x to the -2. So that's what I'm going to do to make it my life easier. Okay, that's just going to make it easier. Now I want to caution you. What if this is just a what if this was 1 over x? Would it help me to rewrite this as x to the -1? No, it would not. No, it would not. Because when I add 1 to -1, I get 0, and I divide by 0, and we don't divide by 0. That is a different rule altogether. What is the antiderivative of 1 over x? ln x, okay, ln absolute value of x. So please just note, this would not help me. So I'm just going to write, this is not helpful. Because the antiderivative of 1 over x is ln absolute value of x, plus c. Okay, so just want to make sure we're clear. All right, here we go. So let's do our reversal power rule. So I'm going to add 1 to 1/2. It's a fraction. So I'm going to add 2 over 2 to 1 over 2. I add 2 over 2 to 1 over 2, and I get 3 over 2. And I divide by 3 over 2. Dividing by 3 over 2 is the same thing as multiplying by 2 over 3. And that's my first antiderivative. Okay? Minus. I add 1 to -2. -2 plus 1 is -1. So I've got x to -1, and I divide by -1, which is the same thing as multiplying by -1. Okay, I'm going to rewrite that so my life is easier. Okay, I'm going to rewrite that to be 2/3 x to 3/2, because I'm getting ready to plug numbers into it. Minus and minus is plus, and I'm going to write that as 1 over x. It's going to be easier for me to plug numbers into it, and I got a 1 and a 4 there. Okay, so I just rewrote it to make my life easier. How are we doing? Okay, so I'm going to take my upper one and I'm going to put it where the x's are. Okay, so we've got 2/3, 4 to the 3/2 plus 1/4 minus, and I put my bracket. Now I'm going to take the lower one and I'm going to put it everywhere there's an x. So I've got 2/3, 1 to the 3/2 plus 1/1. Okay. We're done with calculus. Now we're working on arithmetic. Yes, you would need to know what 4 to the 3/2 is. Okay, so let's talk about it. Here's what I like to do. You really have two choices. What I like to do, this bottom number, if you recall from Algebra 2 and Pre-Cal, the bottom number is the kind of root, right? This is a square root, and then we cube it. So you could cube 4 and then square root it. That's painful. I'm not very good with big numbers. I would prefer to square root 4 first. Okay, so I'm going to write the 2, just bring the 2/3 down. I'm going to do the square root of 4. The square root of 4 is 2. 2 cubed is 8. Plus 1/4 minus. Okay, that's what I would do. So let's see what we got. 1 is delightful. So basically this is 1 to anything is 1. So I've got 2/3 plus 1. So 2/3 plus 3/3. 2/3 plus 3/3 is 5/3. And it's just one thing, so I don't really need the bracket. Okay, again, we're just doing arithmetic. So I've got, what have I got? I got 16/3 plus 1/4 minus 5/3. Now what I would do, the way my mind works is I would want to combine the two that have the same denominator together first. That's what I would do. Just to make it smaller. So I've got 16/3 minus 5/3 would be what? 11/3. So 11/3 plus 1/4. And this is just lovely arithmetic. I need a common denominator, and I can see the common denominator is 12. So I need to multiply this by 4/4 and this by 3/3. So I've got, what do I have? I have 44/12 plus 3/12, which gives me 47/12. And that's my answer. So there's one that the antiderivative wasn't too bad. The arithmetic was a little worse because we had to raise something to the 3/2 power. And yes, you need to be able to do that by hand. Okay, are we okay? All right, let's look at the second one on this page. So, okay, so if I had taken the derivative of something and got a +4 sign, what would I have taken the derivative of? Yep, -4 cosine. Okay, -4 cosine is what I would have taken the derivative of. So that's going to equal, we're going to do our f of b minus f of a. So -4 times cosine of pi/2 minus -4 times cosine of 0. Okay, unit circle values, still important. So let's think about our unit circle. Pi/2 is right here. What is cosine of pi/2? It's 0. So this is 0. Okay, that's easy. Minus. A minus minus. Are y'all okay if I put a plus? Minus minus is a plus, right? So what is cosine of 0? And 0 is right here. What is cosine of 0? 1. So it's 4 times 1, or 0 plus 4 is 4. My answer is 4. What did we just do? I want to make sure we're clear. What did we just do? So if I draw a picture of 4 sine, right? If I draw a picture of 4 sine, remember, oh goodness, I love trig so much. Okay, I know I'm a weirdo. It's okay. So this would be pi, right? That would be 2 pi. Pi over 2 would be right here, right? So what did we just do? What we just did is we calculated, we found the area under the curve of sine from 0 to pi over 2. Isn't that fun? We did it with calculus. Who would think that would be like 4? That's crazy. Okay. We have 2 more problems left. Here we go. We're getting just a little different. Now they give us, they don't have the integral set up for us, so apparently we're going to have to do something. So they give us a derivative, and they give us position numbers. Okay. So apparently we're supposed to find the antiderivative of this because these are position numbers. So let's talk about how we would set this integral up. We're going to integrate this thing, x squared minus 2 dx. And why did I put the dx? Because that's when we're going to stop. That's when we're going to stop. So there's actually 2 ways to do this. And I guess we'll talk about both ways. I'll just talk about both ways. We can do it with an indefinite integral like this. So let's do it this way first. We can do it with an indefinite integral. And then we can use this to find c. And then we can find f of 3. We'll call this method 1. We'll just call this one what we're doing. This is method 1. And it doesn't matter to me which way you do this. It really doesn't. Okay, so method 1, we're going to do the antiderivative. The antiderivative of x squared is 1/3 x cubed. The antiderivative of negative 2 is negative 2x plus c. Okay, and that would be f of x equals, right? So to find c, we've done this before. We would take this in a different context. We would take this and we're going to sub it in. So this is my y value. So negative 2 equals 1/3. My x value is 1 minus 2 times 1 plus c. And now I do arithmetic to find c. Okay, we can do that. So arithmetic. So let's see. 1 cubed is 1. So that's 1/3 minus 2 plus c. So I move the 2 over. And that goes away, right? Add 2 is 0. So basically c is negative 1/3. Okay, so f of x is 1/3 x cubed minus 2x minus 1/3. I want to find f of 3. F of 3 would be 1/3 times 3 cubed minus 2 times 3 minus 1/3. That's why I'm just doing my arithmetic. I'm plugging in, finding out what that is. So 3 cubed is what? 27. 27 divided by 3 is 9 minus 6 minus 1/3. So let's see, 9 minus 6 is 3. 3 minus 1/3 is 2 2/3. Or if we wanted to write it as a improper, it would be what, 6, 7, 8. It would be 8/3. Okay, that's method 1. We do an indefinite integral. We do our plus c. We find c. We plug back in. Okay, I'm going to pause here for a second. Is everybody okay with method 1? Okay, let's look at method 2. Okay, and I'm going to shrink this a little bit so this is method 2. On method 2, we're going to do a definite integral. A definite integral. So I'm going to do the integral from 1 to 3 of x squared minus 2 dx. And now let's talk about why I'm doing the integral from 1 to 3. Where did I get those numbers? I got the number from here. This is this x value that I have and the x value that I want. I would put on the bounds the x value that I have and the x value that I want. That's where the numbers come from. Okay? Uh-huh.
Sorry, I have a question.
Yes.
When you did that there, when you did 1/3 times 3 to the 3rd,
Uh-huh.
is that not
It's
9/3?
So 3 to the 3rd is 27, right? Not 3 squared, 3 to the 3rd.
Yeah, okay.
3 to the 3rd is 27, and 27 divided by 3 is 9. Is that okay?
Yeah.
You're welcome. Uh-huh. Okay, are we okay with the setup of method 2? So where did I get the x values? This is the thing that drives students crazy. Where did you get those x values? Well, I got them because they're the only x values they gave me, right? The x value that I have and the x value that I want. Is everybody okay with the setup? All right, so now we just work this out, okay, using the fundamental theorem. So this is going to equal f of 3 minus f of 1. Okay, so I do my antiderivative. I get 1/3 x cubed minus 2x, and I evaluate from 1 to 3. And that, would equal f of 3. Let's see, we got one of them. Which one did they give us? They gave us f of -1. So, excuse me, f of 1. F of 3 minus, and f of 1 is -2. Okay. So now I'm going to take this, sub that in. And then I'm going to take this and sub it in. So here we go. So I have 1/3 times 3 cubed minus 2 times 3 minus, I'm going to put the 1 in, 1/3 times 1 cubed minus 2 times 1, and that equals f of 3 plus 2. Okay, are we all right? Here we go. Okay, so here we've got the 3 cubed divided by 3, so that's 27, so that's 9, minus 6. This is minus 1/3 plus 2 equals f of 3 plus 2. I'm solving for f of 3, so I would move the 2 over. I hope we see that that 2 and that 2 would be 0. So f of 3 is, let's see, 9 minus 6 is 3. 3 minus 1/3 would be 2 and 2/3, or let's see, 6 or 8/3. Isn't that what I got up here? Okay, I want you to look at those two methods. You are going to get to choose which one you use. They're both great, but it's a choice. Are you with me? Questions?
But for this test, you have to use the other one still?
No, you could use either one you want. Yes, ma'am, either one you want. It'll be fine. Now, on number 5, we're not going to have a choice. On number 5, we have to use method 2. We don't have another choice. Okay, number 5, we have to do method 2. But when you have a question like number 4, you can choose either method.
How do we know which kind of problem to use?
Okay, good question. How would you know which you could do? So when you're given an equation that you can actually take the antiderivative of, that's when you have a choice. I can actually take the antiderivative of x squared minus 2. Okay, that's a thing. It's okay. So I have a choice of either 2. On number 5, actually on number 5, you could actually take the antiderivative of this, but it would require u sub, which we haven't learned yet. okay? And we're using the calculator. For the calculator doesn't really do this whole in this thing with the plus c very well. It doesn't do indefinite integrals with plus c and all that. So if you're using a calculator, you should do, so on method 2, let's just write this out. We would use method 2 if, well, we can use it anyway, mostly, but if we have a calculator, we should do method 2. If we have a calculator, that's the one we should use. Method 2. Okay? So for number 5, we do need to use our calculator. Let me pull mine up real quick. And we're going to go into how this works. Actually, with the calculator, I'm going to do both method 1 and method 2. Oh, no. I'm doing method 2. But I'm doing a variation of method 2. So, okay, so here we go. We want to add calculator. I'm just going to hold that there for a second. Let's pull up our problem and see what it is they want us to do. Okay, if we have a calculator. So this is a calculator problem. Let f be the differential function such that they give us a value. Notice these are our positions. This is a position, and this is a position. They give us position value and want a position, and this is the derivative. There are two different pieces of information. Okay, so we're going to use our calculator. So we're going to do method 2. We're going to integrate from, how do I find out what my x values are? Do I just get to pick whatever I want? No. 1 and 4. 1 and 4. I don't get to pick. It's 1 and 4 because that's what they gave me. I stick in, this would be my, this f prime is the inside part, the integrand. So 2 minus sine of pi x dx equals f of 4 minus f of 1. Okay, this is method 2 from the previous problem. This part I'm going to put in my calculator. I'll put it in my calculator. I'm going to get a number in just 1 second. I'm going to get a number from my calculator. F of 1 is negative 0.25. Oops, that's 4. F of 4 we don't know. Minus F of 1 is negative 0.25. Okay, so I'm going to pause here for a second. Is everybody okay? So we've got it set up. We're going to take our calculator and we're going to put that whole left side in the calculator and just get a number. Okay, so let's pull up our calculator. So there's a lot of ways to get here. I'm just doing one particular way. Okay, the way I like to go is I like to do menu, and I like to do calculus, and I like to do integral. That's how I like to do it. There's other ways you can do it. It doesn't matter to me. That's what I do. Okay, so my bounds are 1, and then 4. And now I need to type in the integrand, that function that we had, which was 2 minus sine of, what was it, pi x. So pi x, and be sure you use the gray x, not this, letter x. Well, I guess actually they don't have a letter. That's nice. And my stop is x. I got to put an x there. Now, if you just hit enter, it's going to give you the weird, just a weird exact answer. Please don't do that. Please hit control enter. We want a decimal approximation. We don't want the real thing. So here's my decimal approximation. I have my calculator set at 5 decimal places. So 6.63662. Okay. If that's not enough decimal places for you, you could grab it and hit enter and see how it's all there. I mean, it gives you like as many as you would want. But 6.63662. Okay, so let's go back to our document. And we're going to write, so this was 6.63662 equals f of 4 plus 0.25. So f of 4, what do I want to do? I want to take that number and I want to subtract 0.25 from it. Okay, which, I mean, we could do with our calculator, right? So calculator, and then I'm going to subtract 0.25 from it. And that gives me 6.38662. Okay, so f of 4 is 6.38662. Now, I only need 3 decimal places, so I can either truncate. So the acceptable answers would be, you could leave that as your answer. That's fine. You can have more. But the smallest you could get is 3. So your answer could be 6.386 if I truncated, or it could be 6.387 if I rounded. Either of those answers is acceptable and the smallest number of decimal places that you could put. It was positive over here, right? And I move it over here because I need to solve for f of 4. Right? No, I got this. This is that. That's this side. That's what I put in my calculator, and that gave me this number right here. And so that number I have to adjust by this number. Okay, so we're going to call this, I'll just call it method 2. We'll just keep, that's method 2 from the other one. But I have a different way to write it. We'll call it method 2B. And this is how you would usually see it on the AP test. So what would they do? They would take the number they were given, the negative 0.25, and they would say negative 0.25 plus the integral from 1 to 4 of 2 minus sine pi x dx. And they would stick that whole thing in their calculator. The whole thing, just like that, and get the answer of 6.386. So that's method 2B. They give you the same thing. Okay? Now, I can go to the calculator and input that. Do we need to see that, or are we okay? Yeah, that would just be the same answer. So how is that different? This one right here, I just want to be clear, this is using the picture, the very picture of Fundamental Theorem Part 1. This is what Fundamental Theorem Part 1 looks like, just like that. What is this one doing? This is kind of, I'm just going to be honest, kind of a little bit of a shortcut. Kind of a little bit of a shortcut where we just, instead of lining it up like this, we just do a little bit of a shortcut. But that gives us the same answer. Are we okay?